Your roadmap to the latest in auto? Welcome to Highway Herald. Today, we're diving into the world of electric vehicles and uncovering some hidden truths behind their touted benefits. While EVs promise greener transportation with lower emissions, the reality of their production comes with various unseen costs. From the environmental impact of battery production to economic and social implications, the true cost of manufacturing EVs extends beyond their eco-friendly driving experience. Let's explore the broader consequences of the EV revolution by delving into these key points. Number 8. The hidden environmental costs of battery mining. Electric vehicles rely on lithium-ion batteries, which need substantial amounts of lithium, cobalt, and nickel. While reducing tailpipe emissions is a priority, the environmental impact of extracting these materials is significant. Mining for lithium and cobalt often happens in ecologically sensitive areas, leading to habitat destruction, soil erosion, and water contamination. In the Democratic Republic of Congo, a major cobalt source, mining practices inflict severe environmental and health damage on local communities. These processes are also energy-intensive, contributing to carbon emissions. Similarly, mining rare earth elements for EV components involves toxic chemicals and produces considerable waste, harming ecosystems and human health. As we move towards electric vehicles, the environmental footprint of battery production requires urgent attention. Number 7. The carbon cost of battery production. The manufacturing of EV batteries is not as clean as it might seem. Producing these batteries involves significant energy consumption, much of which comes from fossil fuels, leading to a substantial carbon footprint that can offset the environmental benefits of driving an EV. For example, producing a single lithium-ion battery can emit up to 100 kilograms of CO2 equivalent per kilowatt-hour of battery capacity. As battery technology advances and larger capacities are required, these emissions can accumulate significantly. The reliance on coal and other non-renewable energy sources in battery manufacturing plants further exacerbates this issue. Moreover, the carbon footprint associated with battery production varies depending on the region and energy mix of the manufacturing facility. As the industry expands, addressing the energy sources used in battery production is essential to minimizing the overall carbon impact of EVs. Number 6. Economic challenges in expanding EV production. The rapid expansion of EV manufacturing presents numerous economic challenges. Scaling up production to meet rising demand requires massive investments in new facilities, technology, and infrastructure, resulting in significant costs for consumers. Building and maintaining battery production facilities involve not only substantial financial investments, but also complex logistical considerations. Securing a stable supply of raw materials, managing supply chain disruptions, and ensuring battery quality and safety add layers of economic complexity. These factors can lead to higher prices for EVs, making them less accessible to the average consumer. Furthermore, the economic viability of scaling up production is closely tied to market dynamics and government policies. Subsidies and incentives play a crucial role in supporting the industry, but these financial supports also have broader economic implications. Balancing the growth of EV production with economic stability is a critical challenge facing the automotive industry. Before we delve deeper, we'd appreciate it if you could subscribe to Highway Herald. Your support fuels our passion to create more content like this. Now let's explore number 5. Ethical and social issues in material sourcing. As the number of EVs on the road increases, so does the need for efficient battery recycling systems. However, recycling lithium-ion batteries is complex and energy-intensive, with current methods struggling to recover valuable materials like lithium and cobalt effectively. Recycling technologies can be expensive and require substantial energy input, offsetting some environmental benefits. Additionally, the infrastructure for battery recycling is still developing, leading to gaps in collection and processing capabilities. Improving battery recycling technologies and developing more efficient methods is crucial for reducing the environmental impact of EV batteries. As the industry grows, investing in advanced recycling solutions and expanding recycling infrastructure will be essential for mitigating the hidden costs associated with battery disposal. Number 4. The energy burden of battery recycling. The quest for materials used in EV batteries raises significant social and ethical concerns. Many mining operations are linked to human rights abuses, such as poor working conditions, child labor, and the exploitation of local communities. Take the Democratic Republic of Congo, a major source of cobalt, for instance. The country's mining practices often come under scrutiny for severe labor violations and environmental damage. The lack of oversight and regulation in these areas exacerbates the social issues related to material sourcing. Addressing these ethical concerns requires a multifaceted approach, including stricter regulations, increased transparency in supply chains, and support for fair trade practices. Both consumers and manufacturers need to be aware of these social implications and advocate for more ethical practices in sourcing materials. Number 3. Global supply chain pressures in the EV era. The surge in electric vehicle demand is straining global supply chains. The automotive industry's complex network of suppliers and manufacturers has revealed vulnerabilities due to rapid EV production growth. A major issue is the concentration of key materials like lithium, cobalt, and rare earth elements in specific regions. Lithium from South America, cobalt from the Democratic Republic of Congo, and rare earths from China. This geographic concentration introduces supply chain risks, including price volatility and geopolitical tensions. Additionally, the just-in-time manufacturing model can be disrupted by shortages or delays in essential materials, leading to production halts, increased costs, and delays in vehicle delivery. Addressing these challenges requires improved transparency, building strategic reserves, and exploring alternative sources. Developing a more resilient and diversified supply chain is essential for managing the hidden costs of expanding EV production. Number 2. Traditional automotive jobs, adapting to the EV shift. The shift to electric vehicles affects traditional automotive jobs and the broader workforce. Moving from internal combustion engines to electric drivetrains requires new skills, increasing demand for technicians and engineers in EV technology and battery systems. However, this shift may displace workers in conventional roles, such as engine assembly and repair, who will need retraining. This impact extends to the entire automotive ecosystem, including suppliers, dealerships, and maintenance services, potentially reducing service-related jobs due to less engine maintenance. To address these challenges, we need targeted efforts to support workforce transitions, including retraining programs, collaboration between industry and educational institutions, and creating pathways for workers to adapt to new roles. A smooth transition is crucial for economic stability and supporting the growth of the EV industry. Number 1. The road ahead, making EV manufacturing more sustainable. As the automotive industry evolves, addressing the hidden costs of EV manufacturing is essential. Advancements in technology, materials, and production processes are crucial for making electric vehicles more sustainable. Investing in research and development can enhance battery technologies, improve recycling methods, and minimize the environmental impact of material extraction. Innovations such as solid-state batteries and alternative materials could revolutionize the industry. A comprehensive approach to sustainability, covering the entire life cycle of EVs, from production to disposal, is vital for long-term environmental goals. Collaboration among manufacturers, policymakers, and consumers will be key to shaping a sustainable future for EVs. In conclusion, while EVs are often praised as a greener alternative to traditional vehicles, it's important to address the hidden costs of their production. By examining these issues, environmental, economic, and social, we can move towards more sustainable practices and a better future for transportation. Thanks for watching. Don't forget to subscribe to Highway Herald to stay updated on the latest in the automotive world. See you next time.